Binomial logistic regression is a statistical method that can be performed to find out whether there is an association or a relationship between two variables, one of the variable which is an outcome or a response, or a dependent variable that is binary, which means that have two levels in it, such as have the disease or no disease, life or dead. And the other variable, which is independent variable, or the exposure, or the explanatory variable, or the predictor, that is can be ordinal. Ordinal variable are a variable that have levels in it, and it is in order from smallest to the largest. An example of ordinal variable that have categories that are in order, such as age categories, weight categories. The binary logistic regression with a binary outcome and an ordinal predictor will be used to find out whether there is association between levels within the ordinal predictor with the outcome. Here in this STATA view, I had inserted two variables. The first one is the age group variable, which have 4 levels in it. The first level, which is an age of 16 to 24 years. The second level in it, which is 25 to 45 years old. And the third one is 46 to 70, and the fourth one is greater than 70. The first level is given a value of 0. The second is given a value of 1. The third one is given a value of 2, and the fourth one is given a value of 3. This is the categorical variable that have an order in it, so it's an ordinal variable, as the classes or the levels in it are in order. So this is a predictor, ordinal predictor, and the diabetes, which is a disease, is a binary variable that have two levels, whether you have the disease or not. Yes is given a value of 1, no is given a value of 0. For these two variables, the ordinal predictor and the binary outcome, to find out whether there is a relationship between the age levels with having a diabetes or not, then binary logistic regression will be performed. To do that in STATA, here in the command section, we'll do some descriptive statistic analysis. Type tab space, then diabetes, which is the outcome, space, then the predictor, which is ordinal, and it is the age, gr for group, comma, and then col for column. Hit enter. A table is generated here showing the cross tabulation between diabetes and the age group. For the age group that are greater than 70 years old, there are 35 persons that have diabetes, and for the age range from 46 to 70, 25 people, and from 25 to 45, 15 individuals have diabetes, and for the younger group, which is 16 to 24, have 6 participants that have diabetes. To find out whether there is a relationship between the age levels with having a diabetes or developing a diabetes, then binary logistic regression will be performed. And the way to do that, in the command section, type logistic space, then type the outcome, which is diabetes, space, then the ordinal predictor, and I'm going to insert an I here so that it will be recognized as a categories that have, or categorical variable that have more than 2 levels in it, and then type age and then GR and hit enter. A table is generated as shown here, showing that the number of observation are 200 in total, 200 participant. And what is important also, the table shown here, 3 important values: the odds ratio, the p-value, and the 95% confidence interval. And since the age group, which is from 16 to 24, is used as a reference category, each level is compared to that reference category. A constant value is given here, and the way to interpret the outcome is by looking first at the first age group or class or level, which is from 25 to 45 years old, shows that individual with this age range have a 3.1 higher odd ratio of developing or having diabetes compared to the younger group. And this odds ratio is significant as the p-value is less than 0.05. This is also can be stated as the age group 25 to 45 years old have 214% higher chances of having diabetes compared to the younger group, and these chances are significant. The significance level also confirmed by a second method, which is the 95% confidence interval. And since the odds ratio 3.14 falls between the 1.1 and 8.9, which is the lower and the upper values, then this add additional confirmation that the odds ratio is significant, and individual in the range of the age from 25 to 45 have 3.1 higher odd ratio of developing or having a diabetes compared to younger age. Looking at the second class of age or group of age from 46 to 70, there is 7.33 higher odd ratio of developing diabetes compared to the reference category or to the younger group, and this higher odds ratio is statistically significant as the p-value is less than 0.05. And looking at the 95% confidence interval of the odds ratio, it shows that 7.3 falls between the lower and the upper value. So this reconfirm that the odds ratio is significant, and also can reinstate that the age group of 46 to 70 have 633% higher chances of developing or getting or having diabetes compared to the younger group. And finally, looking at the age group that is greater than 70, as shown here in the odds ratio, those individuals have 17.12 times higher odds ratio compared to the younger group, and this ratio or odds ratio is statistically significant as the p-value is less than 0.05, and the confidence interval, which is 95%, also contains the value of 17.1, and the upper and lower value does not contain a value of 1. So this reconfirms that there are 1,600% chances of having a diabetes for this group compared to younger group, and this is significant as confirmed by the p-value and the 95% confidence interval. So this is the way to do binary logistic regression with ordinal predictor in STATA.